49 on this Sunday morning. It's time to have a little bit of science fun. Carl Nelson's here from the Imagination Station. Hello.
Hello. You're going to want to put your safety glasses on.
Okay, it's that time.
I brought with me today some liquid nitrogen.
Ah, one of your favorites, isn't it?
It is my favorite.
Okay.
And the cool thing about liquid nitrogen, literally, is that it's very, very cold.
Yeah,
right?
You should not be touching it with your bare hands,
correct? We're not going to touch it with our bare hands. But the neat thing about it is it's 320 degrees below zero.
Wow.
And even though it's 320 degrees below zero Fahrenheit, what's it doing inside that beaker?
Boiling.
Exactly, it's boiling. You got it right. Boiling is changing from a liquid to a gas. Most people think that something's boiling has to be very, very hot.
Sure.
It's not the case. It's just changing from a liquid to a gas. In fact, you can do something pretty cool with that fact that it's boiling and creating gas, because the liquid nitrogen is obviously just liquid. But if we take some of that nitrogen and put it in a test tube, okay, you can't see the gas coming off because it's invisible. But if I put a balloon on top, we should be able to see the balloon start to inflate.
Okay.
Now, cool thing is, I want to really get this entire balloon to inflate all the way. But we probably don't have time to wait for that. So
probably not.
I'm just going to dump all the nitrogen in at once to sort of speed things up. Okay? And sort of cap it off.
Okay.
And nitrogen, when it expands from a liquid to a gas, takes up about 800 times more volume.
Oh, wow.
So this balloon,
it's going to pop, is it?
It's probably going to pop once it gets really, really big. In fact, the nitrogen is freezing part of the balloon.
Oh, wow.
And gets very, very brittle, and at some point it will break.
Okay.
And so it's kind of interesting to see what happens with different materials when they get very, very cold.
Sure.
So, Tina, if you can go ahead and hold this like that.
Okay.
And you're going to dip it right into the container of nitrogen.
The middle, the U portion here?
The middle of it. It's just some vinyl tubing, like medical tubing. Perfect.
Take it out?
Well, let's count. 3, 2, 1. Go ahead and take it out and stretch it far apart.
Oh.
It's not going to break.
No.
It's not going to break. But if I put my hand on here, I can warm it up and it'll become much more flexible. A lot of people would think or want to say that you're freezing it.
Yeah.
We're not really freezing it. We're just making it more brittle. Okay, but different materials behave differently. This one is going to warm back up and get real stretchy with my hand.
So it's not going to break. Okay.
It's not going to break. But this vinyl tubing behaves a little bit differently. So what I'm going to do is I'm going to cool this down for a few seconds. If you can take that hammer there, we're going to see what happens if we apply a little force to this sort of material.
Okay.
See what happens. So go ahead and give it a little tap right in the middle.
Oh, wow. I figured that was going to happen. It was going to turn right into almost glass.
This one shatters like glass.
Wow.
Latex versus vinyl, very different. In fact, a racquetball, which normally would be very bouncy.
Sure.
Put it in liquid nitrogen, cool it down.
Oh, wow.
Again, it will shatter like glass. So some really interesting material science that you can do when you have something available like this that allows you to cool things down from room temperature to 320 degrees below zero.
Interesting. So it's all about the material then.
Different materials behave differently.
Okay.
The classic demonstration are flowers. If I brought some flowers, they have water in them, and that water will freeze. That's really freezing, turning to ice, and those will shatter like glass. But I thought the vinyl and the rubber is a little bit different in some respects.
Interesting. And just a reminder for everybody at home here, obviously liquid nitrogen needs to be used under supervision and only the experts, right?
Exactly. You're not going to be able to go out to the store and buy liquid nitrogen. We actually get it from a gas supply company in town.
All right, sounds good. Carl Nelson from the Imagination Station, everybody. Just a reminder, if you want to head down there to check out some of the experiments, you can do so today, Tuesday through Saturday, 10 to 5, and then Sunday from noon to 5. Carl, thanks so much for coming in. From there, we want to go over to Dave Holmes. He has a check of sports.